a little later than I'm usually in my shop, but I've just been distracted right up until now, so the whole day's gone by. So I think what I really still want to try and do is get the necessary number of tubes in here and get the heaters operating on them. That's just my CB radio going here. Let me just shut it down. Yeah, skip is on again. Excuse me. So last time I hooked up some power to the heater rail, I was surprised to find some current flowing with no tubes plugged in. I think I might know what that's about now. So let's just back up here a little bit. So we didn't really look at the meter that's on the radio here. So there's no indication what this meter is, but what it looks like when I look at the wiring, it appears to be connected right across the heater rails. And this says volume right on here. Okay, so I'm going to set that in the middle. Apply some power and see what this meter does here. There's an indication on the back of the meter of a plus and minus. Plus. That's as loose as can be. Very loose. Okay, now we're going to have trouble making good connections here, I'm pretty sure. So I'll just try to get around that somehow. Okay, we want to be able to see the meter and see the meter. Didn't move at all, eh? Okay, so that answers the question of why there's current. This is also set to read current, not voltage, and it's like 3 milliamps, but it's all going in there. That's great, the meter works. That's fantastic. That also means I should be able to plug some tubes in here and get some heating up. Now I've taken out tubes I've previously tested and proven, or proven that they're good. So I'm going to pop the first one in. Should really watch the current meter. I've got a rather small power supply to do this. So we'll pop this guy in right here. It's great that that's plexiglass. I'm going to have to clean it up so we can really see through it here. Okay. Watch that meter. It's this meter here. Tube in. Holy smokes. One tube. Okay, you know what? I really should have been a little more careful about the voltage here. I was thinking more. Whoops. Yeah, so on this very poor meter, it's a couple volts. The tube itself. See, it's heated up, but these tubes are meant to run yellow hot, not red. The red was an innovation in the tube tube cathodes, so they didn't have to be made so hot to emit electrons. But these ones, they're just, I believe, thoriated tungsten, I think is what they are, and they have to be heated way up. But that's a good start. So we need a voltmeter to continue here. We need a voltmeter. I need to clear my throat. Voltmeter and some other stuff that we can do this in kind of a safe way. Okay, so my objective here, I'm afraid I just can't get the camera shots really good for this, is to watch this meter, and that one at the same time. This one's showing the voltage across the tube filament. O1As use 5 volts normally. This is on the 5 volt scale, so when the meter gets up to the top, the tube is getting its voltage. Anyway, this is a fairly small power supply, and I doubt it can supply enough current to power, well, to power all these tubes. So they want to heat them up and then leave them cooking. So the other thing I'd like to do is, as I plug each tube in, to see the current jump as I plug it in. It lets me know it's made contact here. Okay, so maybe what I'll do, okay, so can't see what I'm up to. Let me move the camera a little bit more forward. There, now you can just concentrate on those meters. Okay, here we go. I'm about to shove it in. This is the one I'm most worried about. Well, I didn't see anything happen there. Did it go down? Now I gotta pop it out. Well, let's keep going. Next tube. So these are tubes that I tested some time ago, not long ago, and I deemed them working at that time. Here goes the next one. Watching the current meter. Really have my eyes on that meter, so I don't know if that. What is it on now? 1.3. Okay, next tube. This is not going at all the way I would have expected it. Each time I put a tube in, I expect that current to go up. Here we go, next one. Nothing again. It's a little unnerving. Oh my gosh, I see what I've done. I've had this on volts, for crying out loud, also. Okay, down a little bit. Over there. That's the current. Aha, okay, yeah. There was something going wrong. I've got almost no voltage applied, and the current is just about at its maximum here. That's all that is good for. Well, this is barely enough. I don't think I'm going to get any real heating effect in these tubes. Now I don't know which ones worked. We're going to assume they all worked so far. Okay, so I do have a much more powerful power supply, but for crying out loud, its lowest voltage is 6 volts. It's very nerve-wracking with these tubes. Okay, gotta think of what to do here. Okay, so up behind here, usually hidden by my clock, is another DC power supply, and that one put out 25 amps continuously. We don't need anything like that. The problem is it wants to start at 6 volts or so. So we're going to find out what its real open circuit minimum voltage is. Okay, here we go. just under 6. Don't think I can turn it down any lower. So the question would be, do I dare use this? There'll be a slight drop when I start drawing current, so it's gonna go below this. Can this really be too much for these tubes? You know, I don't think so actually. Let's turn the power off. Must be big filter. Capacitors in there. Okay, with that in mind. So I'm going to put these right on the terminals here. And no wonder they have hangers for airplanes. I kind of need that for this thing. Holy smokes. That's my supply dying out. Positive. Back of the meter, positive. Positive. If these are tight, I don't want. Oh, that one's loose. Don't want to. So this one will be the negative one. It's good and tight. I'd rather not disturb it. Okay, and then this one. Wow, that's tight. Do some damage to it. Another opportunity is to go further down. It's tight too. Come on. Okay, let's put a tool to it. This meter again, because I need a little bit of certainty here. My other meter should be calibrated. This one up there should be calibrated fine, but just to be sure. Okay, because I'm going to hit the switch and the voltage is going to be there. Now, let's stick another tube in. That'd be a good idea. Get them all in there. I need one more. I need one more for the oscillator. Okay, well I won't worry about that a minute. Let's do these. See where we're at here. Okay, just trying to think. Put a meter on the front, but you can't do anything to these controls that cause that meter to change. So that would mean all this is just voltage from the batteries. Maybe that's all it is. You just keep an eye on your battery voltage. The primary, shouldn't use the word, the main difficulty in operating these radios when it comes to batteries was the battery that did the heaters. So maybe this is to keep an eye on it. I mean, people weren't exactly pulling out their digital voltmeters back then to check things. Okay, and we're good. We're good to go. That's a bad way of putting it, isn't it? Here we go. That's just as bad. Good luck to us. Geronimo. Well, it's signaling that there's a short. It's going to do that for a bit. I've switched it off. It's going to... One of the tubes I put in has a short in it. This lead here has swung over and shorted things out. I think that might be the answer right there. Ready for another try? Here we go. That's way too big. Screwdriver. One of these tubes not an OA1, an O1A rather. O1A. That's fine. So it says 201A right on it. So didn't I operate it with these four successfully? Let's try this. There we go. So hesitant on this stuff. Okay, here we go. Could be that I just can't start that supply up with the load on it. That's probably what's happening here. Well, that's just about the worst situation. Wire off, power on. There we go. That power supply has a fan in it. You noticed. Why did it kind of spark it up against it? Not too bad. That's not too bad, eh? 5.4. So look at. Okay, I'm gonna just pick the camera up here. Hot diggity dog on one of them. Boy, oh boy. Now I don't think that's ridiculous from this kind of tube. These glow almost like light bulbs. Okay, so look at the situation I'm in now. How am I gonna? Can't very well spend my day like this. Okay, we're gonna break it. Fix up a little switch. I think the answer is yes. I'm gonna fix the little switch up so we can switch it on and off there. Okay, I got my switch kind of stuck in here awkwardly, and I don't know which way the switch is. Open or closed. So I put the power on. We'll know in a moment. Isn't that interesting? We didn't get the alarm from the power supply, but nothing is running here. Okay, power on. Yeah, that's awkward. This is just right on 5. So this is a voltmeter here, and it's accurate. 5.5. That's fine, I'm sure. Okay, let's give the darkness test here. So some of these have the top is covered with the getter. So you can't see through them. This one's different. You can see through this one. The getter's down on the side of it here. So they're all glowing along quite brightly. I can look down towards the base, and you can see if you compare the bases of the tubes, they all look very similar. Easier with my eye. So I think they're all heating up reasonably well. And the idea, was my objective here, was to get these tubes heated. The theory being that given some time, the getter would collect any gas ions that might be in these tubes. Boy, I talk a lot slower in the evening. Now, how hot are these things going to get? I don't know if they're going to get hot at all. Like this, just they're ice cold. Even with that going, ice cold. So part of the theory that I'd read about this is, it looks like there's an X marked on this tube. Well, that light is coming out of the tube. Must just be an area. That's really strange. Okay, once again, small things fascinate me regularly. it's just kind of weird. There's a light spot on the side of the tube. Well, the one with the X on it. Yeah, I've said enough, haven't I? I think I need to get one more working tube in here, so I have a full complement, and then we can start actually trying to make the radio do some radio stuff, which I'm guessing is going to be pretty much a lot of fun. Okay, another tube. Okay, well, I did manage to find another one. Here it is here. So now I've got a complement of 6 tubes to work with, but looking at the circuit, I think maybe I don't need a tube in this position. I can tap the audio that's coming to this tube, tap it off to amplify it. So I may have actually a spare O1A tube. Great. Can you let that just sit and do its thing for a while? And we'll carry on. Okay, tubes have been on for a while now, and I've made a little bit of progress in getting ready to apply B+, C- voltages. I'm just going to get rid of this voltmeter. Here we go. Previous owner or builder of this radio put some very valuable notations down here. C-, B-, 135, 85, 45, plus A, plus minus A. I'm not sure what's going on here. So one of the voltages I need to supply into the radio is the C voltage. The C voltage is the bias voltage. There's a C- there. The plus C goes here. Here's my C voltage supply, and that's coming from this variable DC voltage supply with a C voltage or a low voltage and a high voltage over here, B voltage. And that's what I'll be using once we get around to it. So on the B+ side, the radio can be broken into 3 pieces. So you have the audio section, which is down here, and that has its own B+ line, which can be traced. And that's this one right here, 135. And not surprisingly, it's the highest voltage. Highest voltage, most power through the tube, make the speaker work. Then we have 85 volts, and this I'm a little confused about just where this one's going. Somewhere down in this area. And then we have 45 volts, and this is heading right into this whole row of IF transformers. So it's heading for the plates of all these tubes. So this is the one I want to power up, if I'm going to power anything up. And the C- voltage may not have any bearing on the earlier stages that I'm interested in operating. It does come back here, connects to the secondary here. Likewise over here, doesn't go anywhere else. So I'm not going to need the C-, just to operate the. So I'm just going to move this cord over here, and presto. This will now have the B+ voltage on it. B- goes here. 45 volt B+ goes here. I want to monitor this fairly carefully. Excuse me. ignore my muttering right now. Okay, I think we're ready to go. This meter I will set up to show the B plus voltage. .50 volt full scale, so this should come right up. Excuse me, essentially full scale. This is the heater voltage. This is the heater voltage. I'm so surprised this is so accurate. And this one is going to be B plus. Now, so I put B plus onto the radio and it starts working. How am I ever going to know? I kind of didn't think of that till just now. So we're going to listen to it. So my thinking is the way this radio is set up is the first two stages are RF stages. You know, it could be only the first stage. The very first tube is an RF tube. So we'll start on that basis. Take my tracer here. I have to attach this to the ground. Probably the B minus back here would be the right place, but this is a bit too short. Okay, B minus. Best place I can actually connect it for that is up here. Really? Yeah, I don't know about that. That's okay. I'm just going to tug on that. Now I already have the outdoor antenna connected here for some silly reason. I actually have an antenna hooked up to that radio. Now, we want this to be on radio mode and we want it to be on B band. This is just a radio now. Or I'm just not the best antenna. So we're not going to get any stations, but we might if I put it on the antenna, particularly if I take a moment and turn the antenna on. Okay, let's give this a try. So I'm going to tune the radio to where I think it should pick up a station. Right around here. We're going to make contact with the antenna. Hopefully this is long enough. I can make it. My hand on the volume control here. Oh, it swung. Terrible, that noise. Okay, so anyway, we heard something. That's what's heading into this radio. Now, if I start applying beep, let's see what's getting through these coils, if anything. Now, not that this is a perfect way of doing this by any means. So we heard what was there. Here's what's here.
Since 2002, that's a lot more than getting to you.
Well, a lot's getting to that coil. Not much getting beyond it. So I've just turned the volume down a bit there. I'm going to turn this control. Wait a minute here. What are you looking at? So I'm curious about the effect of this control here. And this. It just looks like you're loosening a holding bolt, but it doesn't come out. I don't think that made any difference at all. Don't even need the radio on to be doing this. Oh. The clip lead is a bit of an antenna. It sounded like this touched something up under here, just for a moment there. If there's a break, like let's say this is a transformer here, which it quite likely is, if there's a break in the coil, then that's it for the radio until that is dealt with. Unless we just bypass this whole thing and try to just bring the antenna signal right in on this. I'm assuming this is where it must go from there. I mean, the only way to get from over here to over here is to go through this thing here, so let's do that. So, well, that didn't make any difference. Okay, bit of a bogus deal there. Okay, so we're just going to bypass this coil and apply the antenna here. Okay, let's just try the magic resistor here. Ooh, 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 ooh. Okay, so signal gets right through this thing somehow. So now it's on the grid of this tube. There's no B plus on this tube. Plate is here. Maybe here, just barely. Okay, so we're going to start applying a bit of B plus. See what happens here. Oh my my. I'm going to want to grab this again. Where's all the noise? This is a bad clip lead. Like it. So I'm going to listen to what is on the plate or across the primary of this transformer. Go here. Very good. I'm going to turn up the signal tracer a little bit. Okay. Ready now. Be advancing the B plus, and I guess that's the thing to watch. This meter, 50 volts when it gets to the top, and this meter, it's a little hard to see there, isn't it? Well, that's volts, that's current. We don't want this getting past the red line. And this guy, well, it's 100 volts here. We're aiming for 45, so this meter's hardly going to come up. This is really the one to watch over here for that. At the same time, we're listening. As the B plus gets on the plate, if this thing is actually working, we're going to hear more of that. More of that. I step forward, I'm going to stick my arm right in front of the voltmeter. I yell duck. You don't know what I'm getting at. Here we go. Good, focus. Hey. A little dark in here, I guess, for the camera. Wow, okay, built up lots of tension here. In me, anyway. Let's let her rip. First, I gotta warm it up. More time. should be ready. Something came out of the signal tracer when I did that. Here we go. Keep my eye on that meter. Let's see it go up. There it is. Oh! I'm going to turn down the volume. Advance to B+. Wow, you know, when things work out like that, I think, no, it didn't just work, did it? It did what I sort of thought might happen. Wow. Okay, so what this means is the very first tube is busy beefing up the signal from the antenna. But I think this next tube is doing something else. And I think the next question we gotta ask is the oscillator oscillating? This one here. Is the oscillator oscillating? Well, I didn't hear an answer, so what I'm going to do is I'm going to set up a little test here to find out. Okay, so what I've done is this lead. It's just a clip lead clipped together. I mean, this is literally shorted out. That's my pickup coil. Just throwing it in this area here where there's the oscillator capacitor and the oscillator coil. I'm sure that's the oscillator tube. And all that combined should have some kind of, hopefully some kind of radiation emanating from it. I hate to use the word radiation. Some kind of RF coming from it. Whoa, that's going a little too far. So that's the antenna to my SDR. So we're going to look at the SDR and see what we can see. Now, I'm going to put my hand near the antenna there and see if you don't see. Maybe I'll touch the clip. You know, it is shorted out there. There we go. So you see in the far right, in effect, that's me holding on to the clips. They are shorted together. So. Now, I'm trusting there's a strong signal here. What I'm going to do is I'm going to turn the oscillator adjustment, the capacitor. Just going to watch the screen and see if anything moves. I'm turning it now. Hey, well, I'll be. Whoa! I'm stunned. It's not where I expected it, though. Look at that. It was right through the broadcast band. I'm almost, let's see, this is capacitor fully open. It's just right at the right there. Come back. What exactly are we seeing here? And that's the end of the run. That's really suspicious that it tracks exactly through the medium wave band. But if it's an oscillator, it shouldn't be there. It should be somewhere else. So it could be that the oscillator is not operating at all, but what is operating is some kind of tuning sensitivity that you would expect through the AM band. So in other words, if I tune to, let's try this. We'll try tuning. See, it's around 900 there. We'll bring it down. We can get to 680 or 640 even. Oh, it's kind of weak down here, isn't it? Let's try, we could try up around 1010. There is a signal there. That could be a radio station. Oh my gosh, you know what? You can listen to this with my SDR if I just click right here. Yeah, no, sorry. That was a little much. Tune the radio some more. This on 680. I'll tune through that. I'll tune this control. Okay, we're going to try the same thing even lower at 640. Stronger AM station there. Right there. Let's turn this up a bit. Yeah. Tune the radio. So what I'm going to tune the other tuning control, the mixer control. Well, let's do it. There we go. Anything happen? I don't think so. That's capacitor closed. Rapidly now. Capacitor open. I didn't see anything happen. Let's go up here. Let's go way up here where this thing seems to be very sensitive. Let's see if we can't pick something up here. We go to 1010. We should be able to, I think, this time of night, hear that. What's that? My cat. Nope. Okay, I'm going to tune the radio to that. Let's keep going up. Just turning all knobs. Not sure what that was. Well, it's all pretty interesting stuff. Wow, I have to go. I think that was a good time to stop because after all, it's it's 10 o'clock at night now. So I'm not normally in here in the evenings, or when I am, I'm usually doing crazy stuff like this actually. Pretty good. Kind of got a kick out of that. Wow, well, I have to admit I'm really surprised by my own success here with getting somewhere with this radio. I'm not exactly sure where I've gotten to, but there's some radio type stuff happening with it, so that's good. Great, that's great stuff to think about. And I hope you'll join me for the next video. See what more I can get out of it. Thanks for watching. Bye.